Okay, so back to it. Oh, what's this? Yeah, video game study lounge. Video games music. Alright, we started... What did we do last time? We started looking at variables and types. Yeah, types. And type variables. Right. Types are the normal ones, right? Yeah. You got int, integer, float, double, bool, character. And then you can mix them around, right? You have a list of characters, which is a string or whatever. Then you have type variables within your functions. Right? When it just says you need a list of something and you get that something out. Yeah. And then yeah, tuple always becomes a b. That's why first and second works on a tuple. And that's why when we tried a couple of days ago to take the head out of a tuple, that won't work. Because a head, yeah, you take a list of things because they are completely different. Actually, let's there. That's fine. On a pair. Oh yeah. First only works on a pair. Yeah, a tuple of two things. A two tuple. The TWO pull. Yeah. Pair. It's a missed opportunity, right? Not calling it a tuple. A tuple. Missed opportunity. Calling it a pair. Alright. Now we're going to start on Type Classes 101. Type class is a sort of interface that defines some behavior. Okay. If a type is a part of a type class, that means that it supports and implements the behavior the type class describes. Got a blinking phone here. Was distracting me. Okay, if a type is a part of a type class, that means that it supports and implements the behavior of the type that the type class describes. A lot of people coming from object-oriented programming get confused by type classes because they think they are like classes in object-oriented languages. Well, they're not. You can think of them kind of as Java interfaces, only better. All right. I've never really gotten into object-oriented programming a lot because I found it... The abstractions, I found them arbitrary and confusing. And I haven't looked into Java interfaces either, so I have no idea what any of this means. Interface that defines behavior. Right. What's the type signature of the equal function? Oh, is this the type class? Then we have talked about it. Oh, yeah. Right. Alright, so first we get the function, and that contains a type class where you have to have... Right. A type that can be equalized. We talked about this yesterday, yeah. That is a type class. Yeah. So EQ is the type class. EQ says that, yeah, they have to be comparable, I suppose. And I assume there is a, like, the flip of EQ, right? You could probably... Well, that would make sense. Why would you need to have that? You wouldn't. Yeah. Type class is there to restrict. Indeed. Right. Note the equality operator equals is a function. Yeah, so are plus, multiplication, minus, and division. Yeah, they are infix functions. And pretty much all operators. Pretty much? Why do you say this? Why not all operators? If a function is comprised only of special characters, it is considered an infix function by default. Yeah. If we want to examine its type, pass it to another function, or call it as a prefix function, we have to surround it in parentheses. They're not being consistent, right? Because if we wanted to... Right, we could do this. No. Right, we have to put ticks around it. But if we want to change, right? So the way to do it would be this. Right, to be consistent. Instead, we have to do it like this. Which is... Right? Why wouldn't they do, right? When they decided to use ticks to move a function around, why wouldn't it... Okay. Interesting. Ulgetinotam says it is consistent. It's not. Ticks is infix, parenthesis is prefix. I mean, are there any suffixes? Are there any suffix functions? If there aren't, then it's standard location and the extra location. Right, moving it from an infix to a prefix, and moving from a prefix to a suffix. Infix. I suppose you've got a point, yeah. It's extra complicated syntax, but I get it, yeah. Like you say, ticks, infix, parenthesis, prefix. Right, interesting. We see a new thing here. Yeah, the equal greater than symbol. Everything before that symbol is called the class constraints. We can read the previous type declaration like this. The equality function takes any two values that are of the same type and returns a boolean. Yeah, exactly. The type of those two values must be a member of the equality class. This was a class constraint. That's the type class. The EQ type class provides an interface for testing for equality. Any type where it makes sense to test for equality between two values of that type should be a member of the EQ class. Yeah. All standard Haskell types except for IO, the type for dealing with input and output, are functions are part of the EQ type class. Yeah, character, yeah. Wait. We can compare... Oh, this is for if we create our own... types, right? So when we create our own type, we can decide if it should be comparable or no. It probably won't be. Right, the elem function, I don't remember what the elem did. Did it just take? Right. LM, did we just take 3, 4 from a... Wait, no. 2 from a... No. Let's take 1 from a list, right? 1, 2, 3, 4. No? Wait. Shit, this song is so annoying. Let me just... There we go. Right. Alright. Foldable T. I don't know what that means. Right. They have to be readable A. It checks if the element, if it is an element of a list. Oh, right. Right. Is one an element of 1, 2, 3, 4? So, false. Yeah. Yeah. Is it an element of? It has the type of a... Exactly. We check the element and we take a list of those elements and then we get a boolean. Because it uses equality over a list to check whether some value... Yeah. Didn't you say that, like... This is a list. This is a loop, right? This function is a loop function. I thought you said there weren't any loops. Or is it just... Yeah, that is a loop. It's just that we don't design a loop, but there is a loop, isn't it? Hello, Coleman122. Nice to see you again. How are you feeling today? Better? Did it blow over? Alright, some basic type classes. Equality is used for types that support equality testing. Indeed. The functions its members implement are equals equals and not equal to. So if there's an equality class constraint for a type variable in a function, it will use one of these, right? So we only need this, yeah, of course, we only use this constraint when we check for equality. That makes sense. Colgate InnoTab says, I meant for and while. Yeah. There is no way for me to implement a loop. There are loops under the hood. Of course there are, but yeah, there has to be. It's just that I can't make any loops. Well, I can, but I do them through recursion. Indeed. Coleman122 says he just came back from one of the most pointless classes ever. Polish? The language? Why is that pointless? Where all you do is write 10-page letters and read old-ass books for no reason. Well, you do it to learn Polish, no? Coleman? I mean, if you're not interested and have no use for Polish, I can see, yeah, that it becomes pointless for you, but... Right, I don't know Polish, and I have no interest in learning Polish. Yeah, but it checks for equality. All the types we mentioned previously, except for functions, are part of equality, so they can be tested for equality. Yeah, we've done this before. We've checked all these things for equality. Coleman 122 says, I learned it in primary school. I got to choose, right? I had to learn English, and then I got to choose German, French, or Spanish. But that was kind of pointless as well, because I don't know any of those languages, but I did learn it. I went to the classes. There we go. I went to the classes, but I didn't learn. Alright, for stuff that has an ordering. Ord is for types that have an ordering. So that's lists and tuples, right? Wait. Greater than. Oh, right. No, you only need to... Don't need a list. Just greater than. You need something where you can check if it is smaller or... Wait. Isn't that all of these? No, not the strings. Yeah, the strings don't have ordering. But the integers have orderings, and the characters have orderings. And the floats have orders. So no lists and no tuples. There we go. Coleman 122 says, anyway, it doesn't help me in my everyday lives to know which old dead guy made which old book, which is mandated for some asinine reason. Oh yeah, the idea of canon. Actually, I think something that I noticed when checking out schools and looking at languages today, something that I feel is kind of bad is that the things you're talking about, right? The literature, just reading fiction, yeah. I think there's way too little fiction reading in school. Usually, even though I would agree with you that the idea of canon, I don't know about that, but I guess that's what the teachers decide, right? When I went and worked, I forced everybody to read 1984, and that was some old dead guy who wrote a book. And I forced the kid to do that. But it's better, right, if you get to... If the kids, or whoever, right, when you study, if you get to choose your own books, that would make more sense. Right. All the types we've covered so far for functions are part of ORD. ORD covers all the standard comparing functions such as greater than, lesser than, greater or equal, lesser or equal. The compare function takes two ordering members of the same type and return an ordering. Oh. Ordering can be greater than, lesser than, or equal, meaning greater than, lesser than, or equal, respectively. To be a member of ORD, type must first have membership in the prestigious and exclusive equality group. Oh, actually strings work just fine. I don't remember. Zebra is bigger than abracadabra. That's because A and Z, right? They're comparing the first characters. I think so. Colgate Untitled says, why did you do that? Because of canon. Yeah, because canon. I had this idea that, yeah, kids should read 1984. It's a good book to read. Coleman 122 says, I mean, at least that has me a bit intrigued. But that's the thing, right? Every teacher has their own kind of things, and maybe there is some more top-level canon ideas. Yeah, like a top-down structures. Like, I know there's a book in Swedish that every person that has went to school has read this book at least once. I've read it 2 times and seen... No, I've read it 2 times and seen the movie like 3 times. All of it was in school. Yeah, they're just... This idea of canon that becomes ordained from up top, that everybody should read this. And, I mean, there are pros and cons to that. I mean, it's a great book, I suppose. Like, take Lord of the Flies, for example. I read that in school. Almost everybody has read Lord of the Flies, haven't they? In school? Coleman122 says, I am not interested at all about reading some random old books. Volgetinotab says, obviously not this book. Yeah, this book I haven't read in school. But anyway, the new Deep Rock Galactic update rolls out in 2 hours. Oh, nice. Nice. Rock and Stone. Haven't... It's probably gonna be like a year or something before I go back and try that again. Rock and Stone to the bone. Alright, so I'm a little bit confused here. Right, we have the compare function that gives us the ORD value. Right. And ORD wait. I feel like it lost me a little bit here on the way. ORD is for types that have an ordering. Yeah, and all the types can have an ordering. Right. But this... Why does it take... Oh, right. Because without an order, you cannot check for lesser or greater than. So when you check for lesser or greater than, it has to be an ordering value. Right. The same when you do the compare thing. That also has to have an ordering, but you do get the ordering value. From here you just get the Boolean value, but to get the Boolean value, they have to be able to be ordered. Right, I get it now. It's just... Yeah, we're talking about the functions and the values, right? That's exactly what we did here. It's just that we have... These are always only Booleans. These can be Booleans or ordering. Yeah, ordering and ord is not the same. Yeah. Where did we have ord? Yeah, there we go. Ord and ordering is not the same. Yeah. Oh yeah, exactly. Colgatinotap pointed it out. Yeah, you confuse ord with ordering. I did. That's where the confusion was. And so ordering, yeah, that's greater than, lesser than, or equal. We get that through compare. Yeah. These values. Just like true or false are Booleans, these are ordering. That's completely new. I've never seen that in any language before. That's a new type for me. It's probably there somewhere under the hood, but... Right, members of show can be presented as strings. Oh, nice. I like that. All types covered so far, except for functions, are a part of show. The most used function that deals with the show type class is... Oh, shit. Oh, this is the function. This is the This is the class. No. This is the type class. Damn it. Names. I'm terrible with names. Colgatenon says that ord and ordering have similar relationships as EQ and Boolean. Oh, right, exactly. There we go. I like that way to put it. Ord and ordering have a similar relationship as EQ and Boolean. Similar, not quite the same. Right, members of show can be presented as strings. And we can turn everything into a string. And this is a very easy way to turn things into strings, isn't it? Super easy. Right. It takes a value whose type is a member of show and presents it to us as a string. Indeed it does. I wonder... there we go. Nice. Where was he? Where was I? Right, part of show presented as a string. Yeah. Read is sort of the opposite type class to show. The read function takes a string and returns the type which is member of read. Oh yeah. It just... You can take a string in from somewhere else and turn it like a string of code. Yeah, I get that, yeah. It's good if when you mix languages, this is good. If you want to mix languages and you want to have one language output code in another language, you just send it as a string and then you read it. So far, so good. Again, all types covered so far are in this type class. Yeah. But what happens if we just try to read for? Oh, that doesn't work? Yeah, that would be weird. Ambiguous type, variable A in the constraint. Read A arising from the use of read as an interactive. Probable fix, add the type signature that fixes these type variables. What GHCI is telling us here is that it doesn't know what we want in return. Notice that in the previous uses of read we did something with the result afterwards. We did indeed. That way GHCI could infer what kind of result we wanted. Oh, right. The type inference. It doesn't know. Can't infer from a string. If we used it as a boolean, it knew it had to return a bool. But now it knows we want some type that is part of the read class. It just doesn't know which one exactly. Let's take a look at the type of signature of read. All right, read. Yeah, it takes... A must be part of the read class. And then it takes a string and outputs the read class. So, thing is, we don't know. Right, so doing this creates the type inference. So that means that we could explicitly define, right? Shit, I don't remember. This is way too long. Right, we could make our own function. Where is it? Did we not start? Yeah, we could do like this. If we make something like this, add string, right? What we take is a... No, shit. Damn it, I thought I was gonna like say that the read would be become an int, but... Oh, maybe that is it. Let's do the function, right? Add... terrible naming here, but we take a... That is equal to... What, B? No. No. We'd take read A. Read is not a type? Shit, is it not? Wait, where are we? Oh, right, it's a class constraint. Right, it's a constraint, so we need... we need this thing. Need... Right, and then we take a... Shit, would it be something like this? I don't know why. Actually, we take... Alright, that's a better name. No, it's even char make. There we go. Char make, that's a name, right? So here we go. That's the type class. Let's try it out, see if it works. Right, so... Okay, no modules loaded. Wait. Oh, right. Oh, right. Char make makes int. Damn it. Terrible at names, aren't I? Yeah. Right. What's the problem here? What seems to be the problem, sir? Right, let's check this. Couldn't match expected type string with an actual type. Oh, right. Right. A is a rigid type variable bound by... Wait. Couldn't match expected type string with an actual type A. Why not? Ah! Because we need a list, right? Doing a string, so we need a list. Still no, eh? Why not? Oh, actually, now that I think of it, we don't want to read A, we want to read head of A, right? Still doesn't work. All right. Couldn't match the expected type A. I mean, this is just it's anything, right? It's a list of something with the actual type. Oh, A is a string. A is a rigid type variable bound by the type signature for int make for all A. Read A. I guess I'm trying too hard. I don't get this. I don't get this yet. Right, where were we? Right, because we used... I just wanted to know how to not use the type inference. A should be... Well, here? Oh, right. Of course. Still doesn't work though, but... yeah, because this is... Wait, head of... Wait. Is it like this, then? Oh, in the type declaration. Read here. Yeah, we're not reading A, we're reading... Right, now I'm just super confused. Right. Read A. Yeah, we're just copying this, right? No, wait, I'm confused. No, I don't get this at all, so it's better to just don't. Yeah, just don't. I have no idea what I was doing, so let's just give up and not get ahead of ourselves. Right. Read 4, ambiguous type, right? What GHCI is telling us here is that it doesn't know what we want in return, yeah? Notice that the previous use of read, we did something with the results afterwards. That way they could infer what we wanted to read. If we used it as a boolean, we knew to return a boolean, but now it knows we want some type that is part of the read class. It doesn't know which one. Let's take a look at the type signature of a read. All right. The read. All right. It takes something that can be read, which is a string. Is it always a string? Yeah. And it returns... Right, a list of characters to an int. Read takes a list of characters. Oh yeah, read takes a list of characters. Right, it takes a string. And we get A, and A, oh man. This makes my head spin. I don't get it, like at all, the structure, what they're doing. It's like, they're not really describing what they're doing. Yeah, imperative thinking, right? I just want to know, what are you doing? What are you doing? But they're not telling me because they're trying to build a language where you don't do things. You just declare things, right? Alright, so it takes a type class that is part of read, right? Okay, so show takes things that can be presented as strings. So read takes a string that can be evaluated as something else. Is that what read is? It can be evaluated. So read has to be something that can be evaluated as something else. And that's what, oh man. That's the type constraint. It's a string that can be evaluated as something else. And what we do when we use the function read is that we take that string and evaluate it as that other thing. No, a is the return value. Yeah. Oh, right, and a can be anything. It doesn't have to be evaluated. A can be anything. So it could take... Right, if we take... Right, how did we do two strings? Right. Hello. Is this it? World. No, how did I feed a string into a string again? Was it not like that? I wanted to join two strings together. I mean, I guess we could do that. I don't remember why that works, right? But if we do this... Shit, I don't even know where I was going with this. Wait, no, yeah, here we go. This is where I was going with this. No, that won't work. Will it? Yeah, no. How do I make a string that looks like... Right, how do I turn this whole thing into one string? I want to have all of this and read it. Can I even do that? Show. Oh, right. Of course, we just learned that. So we take... what? Show. Oh, right. Just a backslash. Right, I don't have to... I can just do... Right. Do this. And we don't have to do... That's just extra annoying. Whoops. Right. And we could do read. Why not? My thinking was that, right, we have a string. It didn't work. Oh, right, that's why I wanted to do that other thing. Right, that's why we did this thing. because I don't know what I wanted to read as, right? So that's why we do the... that's why I was looking for that. They infer? No. Oh, right. So it's not... Alright. Now we can infer. Wait, why not? Read... oh, shit. There we go. Now we can infer. There we go. Finally. Took a while. So yeah, A can be anything. It can be even a string. Or a list of characters. But that doesn't... yeah, it doesn't get me out of the inference thing. But I guess we will get to that later, yeah. We'll get in tab says read and then double colon int would work. Oh shit, what was double colon again? What did we read that? That was in the very top, wasn't it? As type of int. Oh! Right. That would just work, no? Oh, read. Yeah, we have to read it. Oh man, it's so confusing. Right, where were we? So far so good. Okay. We did something with the result afterwards. Yep, we inferred it. See, it returns a type that is part of read, but if we don't try to use it in some way later, it has no way of knowing which type. Oh, right. It's because it's a lazy language. So this becomes pointless, and I assume that all other situations would be pointless as well, right? We would have to use it for it to make sense. So it's not only that it can infer, it's that it's a good idea to infer when doing reads things, I guess. Here. That's why we can use explicit type annotations. Oh, and this is the type. It's right here, yeah. Type annotations are a way of explicitly saying what type of an expression should be. We do that by adding at the end of the expression and then specifying a type. Yeah. Most expressions are such that the compiler can infer what their type is by itself, but sometimes the compiler doesn't know whether to return a value of type integer or float for an expression like read5. Yeah. To see what the type is, Haskell would have to actually evaluate read5. But since Haskell is a statically typed language, it has to know all the types before the code is compiled. Or in the case of GHCI, evaluated. So we have to tell Haskell, hey, this expression should have this type in case you don't know. Right. Right. Enum members are sequentially ordered types. They can be enumerated. Main advantage of the enum type class is that we can use its type in list ranges. Yeah, we use enum, that's for mapping and zipping and all of those things. They also have a defined successors and predecessors, which you can get with the suck and the red functions. All right, types in this class are different types of tuples. All the tuples, probably. Booleans. Oh. False is 0, true is 1. Characters, the alphabet. Wait. Ordering, that becomes confusing. Isn't ordering... Isn't ordering implied? No, wait, ordering was the GT, yeah, the greater than, smaller than, yeah, I forget. So yeah, so small equal greater, yeah, exactly. They can be enumerated 1, 2, 3 or 0, 1, 2, I guess. Integers, floats, and doubles. Yeah, okay. Yep, they could be listed. Or enumerated. Right, bounded members have an upper and lower bound. Oh yeah, int has a character, wait. Backslash, oh, I don't even know what that is. Is this ASCII? Maybe not. Probably not. The other one. Actually. Oh shit. That's... Wait. I was kind of hoping that... Wait. If we do... Read... No, never mind. Right. Min bound and max bound are interesting because they have a type of bounded A and then A. In a sense, they are polymorphic constants. All tuples are also part of bounded if the components are also in it. Right, max bound, bool, int character. Right, num is a numeric type class. Its members have the property of being able to act like numbers. Let's examine the type of a number. Oh, right, that's T. Why does it take a T here instead of an A? I guess A is more language-wise and you start from T for more number-wise, I guess. And that would be int, integers, floats, and doubles. The nums, right? It appears that whole numbers are also polymorphic constants. They can act like any type that's a member of the num type class. Yep. Those are types that are in the num type class. If we examine the type of multiplication, we'll see that it accepts all numbers. Yeah, since it's num. Alright, it takes two numbers of the same type and returns a number of that type. That's why 5... Did colon stand for again? Has... Shit, I forget. Where was this? Phone is ringing. Actually, I gotta answer this. Adam Mattias? Yes, kommer ut om 2 minuter. Okay. Oh shit, I lost. Has type off. There we go. I lost track of time, so we will have to continue this tomorrow. Where were we? Has type off here somewhere. It might be worth repeating this tomorrow when I'm not as tired, because I think I missed some stuff today. Didn't get it. We'll see. Alright. But, right, early lunch and everything. Gotta go. See you next time. Cheers.